but I'm on it. We were taking notes yesterday, and there are some things that I want you to remember. This is my hint, hint, wink, wink, because like I said, there is a checkpoint quiz happening today. A ratio is a fraction. And then we talked about extended ratio, but really, if I was going to study extended ratio, I would look at problem 3 and problem number 4. There is a question on this checkpoint quiz that looks similar to one of these.
Those are easy.
I think so too. Now flip to the back. We talked about how to cross multiply. There is a cross multiplication problem on these. It involves distributing. So if I were you, I'd study over number 6 specifically. If you were wanting to study before I call you, because you don't want to get trapped with me for the rest of the class period. Okay, the last thing, we have like 3 examples, and we're going to do them quickly. I had other people read, but I need to read now so we can go fast. It says ratio of boys to girls. So that means boys in the numerator, girls in the denominator. Boys to girls. They told me specifically it is 4 to 3, meaning 4 over 3. Now I'm going to set up a proportion, which means 2 ratios with an equal sign in between. I need to plug in that 936. Since it's for boys, and we were doing boys and girls, boys and girls, boys. I need to put that 936 in the numerator. Are there any questions about that? And if I continue to read the question, it says, how many girls are at the high school? So they don't know what number goes here. In math class, when we don't know what goes somewhere, we put an X. We cross multiply, and we'll get 4X equals whatever 3 times 936 is. I need you to calculate that. 2,808. So 4X equals that. If you divide by 4, you get X equals 702. So there, if we wanted to be very specific, there are 702 girls. Now, I do want to mention right here, before we move on to the next thing, that word problem's trickier. The great thing about this section is that it's real life relatable, but the word problems can trick you. For instance, instead of saying there are 936 boys, they could say there are 1,000 total, 700 girls, and then they ask you for the ratio of boys to girls. You would have to be smart enough to know 1,000 minus 700 is 500, so it's 500 over 700. I say that as a wink, wink, hint, hint. There's something on this checkpoint that requires you to actually use your brain to have a second. I did that math wrong, didn't I? Someone fixed me. It should be 4. 3. 7 plus 3 is 10. I did 1,200 every other example today. I'm telling you. Telling you. Okay, I have had Juliana's example up here since yesterday for a reason. She made 300 over 700. It's an ugly 300. She made this great city project, and I think it's pretty realistic in its proportions. Like her park, for instance, isn't swallowing up the rest of the city. Her streets seem about the right width compared to her buildings. She has a scale model. So it's not a real city. Obviously, I can't hold a real city in my hand. But it is a scale model of a city. Similarly, I have a scale model of the Eiffel Tower. It is not the real Eiffel Tower, but it is a model. And it is a realistic model, meaning that these openings are about the same proportions as they are on the real Eiffel Tower. Yeah, it's not the same size, but it is the same dimensions, meaning that we had the same, it's called, what we're using to convert from my pink Eiffel Tower to the real one is called a scale factor. So I've left my highlighter somewhere. If I had it, this is the next vocab word that I would definitely highlight. Okay, when we do a scale factor, we always put our model. Yes, dear.
Okay, can we jump back up, please? Where did you come from again?
300 plus 700 is 1,000. So I knew if there are 1,000 total and there's 700 girls, then there would be 300 boys. 700 is 1,000. Because 300 plus 700 is 1,000, and I was told there's 1,000 total. I was just making a side example. Okay. So, when we do something involving models, and we're trying to figure out this ratio to get me from the real Eiffel Tower to my pink one, we call that the scale factor. And we put the model, like my pink Eiffel Tower, in the numerator, and we put the real thing, like the real Eiffel Tower, in the denominator.
So it would be like 700 to 1?
Yes. So, well, you say that, and it's going to be opposite. It's going to be like 1 to 700. So we're always looking for a super tiny decimal. It's always going to be a decimal less than 1 because our scale is obviously going to be smaller than our real life thing. That's a good question, Dylan. Best one I've had all day. Make sure, the last sentence would be the most important. Make sure you use the same units. Meaning, we got to both be in meters. Both the units are in feet. Both are in inches. They have to be the same before you can put them in a fraction and solve. So our example is about this. It's a toy car. So it's a miniature replica of a 1923 checker cab, and it's 6.5 inches. And then the actual length of the car was 13 feet. What is the scale factor? So we're trying to figure out which numbers to plug in where. I like to put model in the numerator, actual in the denominator. Okay, my model is 6.5 inches because it says miniature replica 6.5 inches. Do I put 13 in the denominator?
No.
Why?
It's not.
We need to convert it into inches. So 13 times 12 to convert it into inches. And what number do you get? 156 inches. Because there are 12 inches in a foot. It's just something you're supposed to know. If you don't know those kind of things, if you ask me, I probably wouldn't be nice enough to tell you. Okay, this section, I know yesterday we harped on Miss Compton would rather see a fraction. I would rather see a fraction when we're talking about ratios. But when it comes to scale factors, I'm okay with a decimal. Especially, you can't make lemonade out of oranges. If they give you a decimal to begin with, I totally understand that your answer is in a decimal. That makes perfect sense to me. So someone type this in your calculator and give me a decimal, please. 1 what? And so the 6 rounds this up, so it's technically 0.042. Okay. Again, like we were discussing yesterday, I'm really looking for 3 decimal places. So that's all we have to do for the scale factor. The hardest thing is making sure they're in the right conversions. Sometimes you don't have to do any conversions, like on this very last example. It says if a map scale is 1 inch to 50 miles, so 1 inch to 50 miles, and the distance on the map between point A and point B is 3.5 inches. How many actual miles apart are point A and point B? So we know 1 inch is 50 miles. So 3.5 inches, I put an X and I cross multiply.
That'd be 170.
When you cross multiply, you get 175 equals X. So that means we have 175 miles. Do you actually have to set up a proportion to solve this problem? No. I probably could have done 50 times 3 is 150. Add a half more, so add 25 more to get 175. This is just how I was going to set it up because that's the kind of section we're on. Now, what I've said all day, and I'll say it now so you don't miss out on my words of wisdom, this problem, number 10, is that what I'm going to call outdated in our life. Because we use our phones, and our phones tell us how to get places now with our navigational systems as our GPS. This would have been useful if we were using a hardcore map like your parents did. When they would plan out a trip, they would actually look on a map, figure out how far somewhere is, figure out how many miles it is. You do this?
We used one a long time ago.
Okay.
I still remember it.
And you figure out exactly, so we're going this far on a map, and that's how many miles, and do I have enough gas, do I have enough food, do I have enough formula for the
I have a
baby?
question on number 9.
I have an answer, yes dear.
Are you always gonna, if it says like 13